Hi guys, welcome to another episode of Ask Dr. Nick. My name is Dr. Nick Schmidlkoffer and I work for the Neurologic Wellness Institute here in downtown Chicago. And on today's episode, we are going to talk about what can I do or what should I do when I expect that I have a concussion or suspect that I have a concussion. And so there are a lot of things that you can do right away. And the very first thing you should do is contact your doctor or maybe go to the emergency room if it's bad enough in order to just rule out some really important findings, rule out some things with some basic tests, whether that be some lab work or an MRI or a CAT scan, just so that you can settle your mind about that nothing out of the ordinary is wrong. But once it's diagnosed as a clear concussion, then you can do things right away that we can help kind of decrease the inflammatory reaction that can occur with a concussion. That is the main proponent of causing a concussion to last longer than just a couple weeks. And so the first thing you want to do is do things that you can decrease the inflammatory reaction. And so we're going to talk about a few ways we can do that, mostly through diet, that we can help help this recovery. And so first what we're going to do is we're going to look at a picture. And so I just want to pull this picture up. And so we're going to look at this one right here of picture of your brain. And this is not a typical picture that you would see of the brain because you don't see any of the outside of the brain or the gray matter, the cortex, what holds the neuron cell bodies. Instead, what we're looking at are a bunch of axons, these fibers that are connecting the cell bodies from the big part of the brain down into the brainstem right here, or even all the way down into the spinal cord. And so the reason why I'm showing you this picture is because there is a vast amount of these fibers that are all going from every part of the brain to multiple other areas. And these fibers are most commonly or most susceptible to brain injury. Because what happens when we have a concussion and we hit our head or we have this like whiplash type injury, we have your brainstem right here, and then on top of it is the actual cortex. And so when the skull moves around, the brain moves around inside the skull. And it will move back and forth. It will shear side to side, and it can also rotate and shear. And all this rotation and moving around is kind of what can disrupt these axons. And by disrupting these axons, we can break them or we can just damage the outside of them so the connectivity doesn't work as well. And this almost creates roadblocks in these connections. And so rather than having this perfectly 4-lane highway just moving right through from downtown Chicago to Milwaukee, that like everybody can fly and just go in 70, 80 miles per hour. Instead, we have these roadblocks where all of a sudden now it's like you only have one lane, and these roadblocks are just making traffic not as efficient, and therefore the connections that are in your brain aren't as efficient. So the best thing to do is we need to kind of break up these roadblocks through different therapies, but also prevent more roadblocks from occurring through this chronic inflammation that occurs during a concussion. And so let's look at what kind of happens more at the cellular level. And so we're going to go to this photograph. And so this photograph is showing, it's just a simple diagram of traumatic brain injury and the different things that can happen. And so we have a cell body here with these little dendrites that are communicating with other neurons. And then we have this long axon. This is that fiber, one of the fibers I was just showing you. And that axon ends down into these terminals that then are going to connect to other neurons. And this is how a neuron sends a signal, is through this long axon. And so we just talked about this axonal shearing that occurs. And this physical impact and injury causes these little tears and an injury to the axon so that this connection can't be sent as well. These are the roadblocks that are occurring. And so besides this, also in a traumatic brain injury, a mild traumatic brain injury, or a concussion, we get these glucose alterations. So this is a picture of a blood cell with a blood vessel with red blood cells in it, and then it's communicating in here with the cell. And so this is how the cell gets its energy, is through glucose and oxygen. And so we know that during a traumatic brain injury, we have this hypermetabolism. Basically, the cell needs more energy. It needs glucose to make this ATP or energy. But what happens is the cell, this neuronal energy production, shifts to a less efficient glycolysis. Glycolysis is the way that glucose is converted into energy. And so if the cell needs more energy and it's getting all this glucose, but glycolysis isn't working well to produce the energy, you just have all this glucose going in and around the cell, but no energy being produced. And so this leads to this acidosis and membrane dysfunction and blood-brain barrier permeability. And so this acidosis is it's producing more inflammation in the cell and around the cells. And so we don't want more glucose going there. So we really want to actually decrease the amount of glucose there in order to get more energy. So this is one way. Another thing that happens is you get this glutamate sensitization. So glutamate is a neurotransmitter that is the most excitable neurotransmitter in the brain, in the central nervous system. And so when a neuron wants to talk to another cell, then it's generally going to release glutamate to send its signal for excitation. But we want that to happen in a controlled fashion. We don't want glutamate to just go all random. And so what happens is, with this breaching of the blood-brain barrier, with the cell membrane being kind of decreased and not as impermeable, then what's going to happen is glutamate leaks out, and you get this glutamate excitotoxicity. So basically, you have too much excitation. This excitation leads to this too much noise. And so there's all this noise around. So just like a little thing can tip the scale and cause this neuron to fire. But we don't want that to happen, because we want it to control this neuronal firing. So this is why a lot of times concussions and brain injury with inflammation can lead to sensitivity to light, sensitivity to sound, migraines, because there's just this too much noise going on and we can't filter it out. Another thing is this calcium influx. Calcium is an important ion that is used to help the neuron send its signal. But same thing happens, that if you have too much calcium inside the cell, we lead to more glutamate being released. And at the same time, calcium in the cell can also tell that neuron to die. Basically, that we have too much, the neuron's too damaged, and that we should undergo what's called apoptosis, or cellular death. And we don't want that to happen to every neuron. We want it to happen to ones that are too damaged and we can't repair. But if there's some that are around that we can improve, then we don't want all this calcium going in and signaling this response. And so another thing is just to decrease this calcium influx. And then the last thing is this microglial activation. Microglia are the cells of the immune system that predominantly are located in the brain. And so they are important because they are going to cause that initial inflammation to help clear out damaged cells and clear out waste. But the problem is, when it gets too activated, we get this prolonged microglial activation, and we have more inflammation than we can handle. And we can't actually clean up and have a good restorative process to occur to help heal the brain injury. And it causes more damage. And so with all this happening, we have a few ways that right away with nutrition that we can decrease these cellular processes from occurring, this inflammatory nature that is occurring in the brain, and make the brain more efficient to help heal itself. Okay. So first one I want to talk about is fasting. Fasting has been shown to be neuroprotective to the brain, and especially after traumatic brain injury. So this is an article specifically from 2008. So right there, 2008. And it is a rat study. But the idea of fasting is that by fasting, we decrease the amount of glucose that is getting into into our brain. By decreasing the glucose, we're not causing more inflammation. At the same time, we're increasing this ketone body metabolism. Ketone bodies are another alternate fuel source for the brain. And so what it does, it's what the goal is of a ketogenic diet, is to increase ketone bodies, because that is a more efficient fuel source for the brain, and it doesn't cause that rise in glucose that can be inflammatory. And so we know that, and this is just some of the findings they found in the rats, is that they decreased biomarkers of oxidative stress or free radicals, which lead to inflammation. It helps improve mitochondrial function as well after injury. And so we just know fasting can be really good for following a brain injury. And so my recommendation would be fasting about 18 to 24 hours, just drinking some water, maybe having some salt with it. And I would say drinking a lot of water and just having some salt. And therefore, that can help just decrease that glucose load in the brain, help increase those ketones as well. Next part would be to improve, or to maybe go transfer into a ketogenic diet after this fast. And so this article is looking at caloric restriction and ketogenic diets. So caloric restriction would be that fast, and then the ketogenic diet is doing the more higher fat, lower carbs, so that we don't increase that glucose, right? And so this article is from, I believe, 2014 here, in the Journal of Lipid Research. And so we have, with a injury, we get this glucose metabolic depression. That's what we just talked about. Glucose isn't used to make energy as well. And so instead, what we can do is we can use these ketone bodies as a natural alternative substrate to glucose for cerebral energy metabolism, or brain energy metabolism. And this is really important, because if ketones can be used, we can kill two birds with one stone. We are not putting glucose into the brain, causing more inflammation. And then we are actually getting ketone bodies to make more energy, which glucose wasn't doing as well. And so let me show you a diagram here. And so this diagram is just showing you what we talked about before. So TBI is going to lead to a decreased glucose into the cell, decreased glucose processing to make energy, or ATP, so decreased ATP. We also have increased oxidative damage, or these free radicals that lead to more damage, more inflammation in the cell. But ketones, on the other hand, can enter through this TCA cycle in the mitochondria. Here's the mitochondria of the cell. And by doing this, we are creating more energy. This is the alternate fuel source. So we're increasing ATP. We're also reducing this mitochondrial, that powerhouse of the cell. We're decreasing the free radical production in there. By decreasing the free radical production, we are not causing as much inflammation. And lastly, it helps increase glutathione. And glutathione is our best endogenous, basically we make it, best endogenous antioxidant. And so therefore, again, we're helping decrease this free radical production, helping limit this inflammation. So after you fast 18 to 24 hours, then we kind of move into a higher fat, moderate protein, low carb diet, ketogenic diet, for 3 to 5 days, right? Just to make sure we keep that inflammation down and not promote it with any extra glucose or sugar. Okay? And then last one here is we can talk about our omega-3 fatty acids. So this is an article from 2016 by Michael D. Lewis. He's a big promoter of omega-3 fatty acids for prevention and treatment of traumatic brain injury and concussions. And I just want to show you one part here. We have a couple different kinds of omega-3 fatty acids. Okay, omega-3 fatty acids are part of the polyunsaturated fatty acids in our diet. And so polyunsaturated fatty acids can be either omega-6 or omega-3. And so omega-6 tend to be more pro-inflammatory. So here it's hard to see, there's like a little cutout, but these are inflammatory, this arachidonic acid. This one can be more anti-inflammatory. But on the other side, we have omega-3s. All omega-3s, especially the ones that are used by our body, the EPA, coursapentanoic acid, and the DHA, docosahexaenoic acid, are going to be pro-resolving and anti-inflammatory. Okay, pro-resolving means it helps resolve inflammation, and anti-inflammatory, it's just promoting these anti-inflammatory processes from occurring. And so we can get omega-3 in our diet by eating salmon. Some people think we can get it by eating more like flax oils, but really the best source is through these small fish like sardines or omega-3 supplements that are liquid, in order to get a lot of EPA and DHA, because that is what we actually use by the body, especially DHA. DHA is predominantly used in the brain, and it's important for not only healing the brain after an injury, but also for neurodevelopment, and therefore it will help kind of clear out the inflammation, but also help this healing process to restore those axons that were damaged, so we can have the better connections. We can take away those roadblocks and improve that highway, okay? And so basically we have three things that we want to do. Let's go back here. And so three things that we want to do to help us improve after we have a concussion is by decreasing inflammation by three things. We have 18 to 24-hour fast to decrease the amount of glucose going in, decrease that inflammation, improve ketone body production. Then followed with a 3 to 5 day ketogenic diet, basically high fat, moderate protein, low carb. And while you're doing that, drinking tons of water, getting more salt, because that kind of a diet can cause dehydration. And then right with that, when you're starting the ketogenic diet, we're also going to increase our omega-3 fatty acids. By increasing omega-3 fatty acids, we really improve that inflammation. And so these three things are things you can do right away if you suspect that you have a concussion, even before you go to the doctor, because going to the doctor might take a day or two or more. And so by doing this and just starting off strong, we can help limit that inflammatory process. Remember, we want the inflammatory process to occur to take out some of the damaged cells and debris, but at the same time, we don't want it to be overactivated. And so this can really help prevent that prolonged or persistent response and persistent symptoms that can occur where you end up having maybe post-concussive syndrome a couple months down the road. So that is all for today. Thank you for tuning in. And if you have any questions or concerns, please leave them below in the comments. Also, if you have any suggestions for future topics that I can talk about and really help other people out as well as yourself, please leave them below. And otherwise, that is all. And so stay healthy, and thank you.